Hello students, in the class I told that I will record JEE advanced questions of previous years. So first we'll start with mechanical properties of solids, and this is small chapter and basically they have asked less number of questions in advance. Next chapter maximum by tomorrow morning or day after tomorrow I will post, that is the gravitation, a very good weightage gravitation has in JEE mains as well as advanced also. And after that thermal properties I will record, and then thermodynamics also I will post. After that, so oscillations and waves also we'll see. Once your syllabus is completed, I try to post all the advanced questions of class 11th from beginning chapter to all. Okay. So whatever I am explaining the questions, PYQs of advanced, before you watch this video, two things you have to do. First thing is revise complete class notes once. Take 15 minutes time and quickly revise class notes of this particular chapter, and then open the video. Now pause the question. Don't solve the question immediately. Just pause the question. You try by yourself. After that, watch the solution. Okay. So let us start. This is the first question. This is the question asked in JEE Advanced 19 level. Very old question I have taken. First question is right, very bold. But whatever the models are, they're important models. All those models I try to cover in this advanced questions. Basically, less questions from this chapter. So, a wire of length L and cross-sectional area A is made of a material of Young's modulus Y. If the wire is stretched by an amount X, the work done is. There is a metallic wire. So again consider metallic wire is elastic nature it has. Then only elongation is possible. Right. Let us consider there is a metallic wire of length L. As per the given question, length mentioned already. So length of the metallic wire is given as L. There is a rigid support, one end is fixed. And it is having mass M. Mass not given, you can consider mass is M, length is L, and AF cross section is A, and Young's modulus is Y. Now here we are applying some force at one end of the wire to elongate this given metallic wire. So applied force is F. So when we apply force, then what happens? This is elastic material, you can see. So one end we are applying the force and we try to stretch this. Whenever we try to stretch a material, elastic material, so that we can see elongation takes place. So instead of solving this question directly, we need to compare with the spring cases. In class I discussed F equals to Kx we will write. Right. So here also you just mention F equals to Kx first of all. So instead of a rod, a spring is given. Then how will we analyze the question? So we can analyze the question like this. The rigid support again. And to the rigid support, a spring has connected. The spring. Now again for the elongation of the spring, we need to apply some external force. Let us take applied external force is F. So whenever I apply some force so that I can elongate it, so elongation can be written as F equals to Kx. So this is the elongation produced in the spring. In this formula, F stands for force, applied force you can say. K is a spring constant and X is the elongation. Same equation I will apply for the case of rod also. For the rod, how much is the force I am applying? I am applying a force of F. This is for spring. And what I am writing here down is for the rod. This is the case of rod I am writing. For a rod, if you apply, there also I am applying a force F only here. Right. So due to my force, what happens? We can see some elongation. How much the elongation we can see? K into delta L we can write. Achha, here the problem is X is elongation directly we can say. Delta L is also elongation. There is no problem in that. But how to write this K value in terms of L, A, Y? Because they have given here some of the properties of the given conducting material. So L value, Y value, how much we need to analyze. So spring force, work done by spring force formula is what? Work done by spring force formula is half into K into X square. This is the work done by spring force. Magnitude I am taking, basically negative will come. That you also know. Similarly, work done by the applied force to stretch this total wire, how much we need to take? That is half into K into delta L into whole square. Now K value I have to represent in terms of LAY. So how to write this? Let us consider, we know one equation, that F equals to, or Y equals to F into L divided by A into delta L. Yes, we know this equation. So Y equals FL by A delta L. How this equation came? Basically, stress is force by area, strain is change in length by original length. So according to Hooke's law, stress is directly proportional to strain. From that, this equation came. I have given in the class. So I will write equation for force here. F can be written as Y into A divided by L into delta L. Now you just compare this equation. Here instead of K, we have represented everything in terms of Y A divided by L. Now substitute this value here. So work done equals to half into, instead of K, now we can write Y A L. So Y into A divided by L into delta L whole square. That's it. Because K value is Y A divided by L. If you compare this entire equation with a spring, then the question becomes easy. So directly you can write the result here. So work done equals to half into Y A divided by L into delta L whole square. So this is the answer for the first question. Clear. Next, second question is, this is 2003 advanced, question number 2. Once you see the question here, the adjacent graph shows the elongation. Elongation is given basically here, delta L of a wire of length 1 meter suspended from the top of a roof at one end and with a load W connected to the other end. If the cross-sectional area of the wire is 10 power minus 6 square meters, calculate the Young's modulus of the material of the wire. So whatever the questions we have discussed in class, in all those questions they have given Young's modulus. We have calculated change in length, how much is the force acting on the given wire for the elongation. Those models we have done. But here in this question they are asking that what is the Young's modulus of the material. So how to find Young's modulus of the material? So let us see this. First of all, to get Young's modulus, what is the relation? So relation between Young's modulus, force, change in length and length. So we need to relate all these quantities. How to relate? According to Young's, Hooke's law, we can write Young's modulus equals to Y equals to FL, Y equals to F into L divided by A into delta L. So Y equals to FL divided by A into delta L. This is the equation. Okay. Y value we don't know. Whatever the quantities they have given, first to write those quantities. In the question they mentioned that area is this much. Area of the wire is given. And load means nothing but force. How much is the force we are applying? That force value is given. And the length of the material also given, length value. Okay. Write those values. Length given as 1 meter. Area is given as 10 to the power of minus 6 square meters. And then force value, here force is nothing but weight of the object. So whatever they have given, just substitute in this equation. Y equals to W into L value is 1 meter divided by area of cross section is 10 to the power of minus 6 into change in length. Delta L stands for change in length. So this is delta L. So what we need to get, W divided by delta L is how much, that we need to find out. For that I will rewrite this equation like, so 1 divided by 10 to the power of minus 6 into delta L by W. We can rewrite this also, there's nothing wrong in this. Now you see the graph here. What is the slope of the graph? How to find the slope of the graph? Slope of the given graph is a constant because it represents a linear graph. So we can say directly that slope is a constant. So I will find the slope between any 2 points. So if you find the slope here, how much you will get here? So slope equals to y-axis quantity, that is delta L divided by W you will get, right? You see the graph, you will understand. Slope is here y-axis quantity given delta L and x-axis quantity given as W. So delta L by W. And what is the slope value we will get if you take here? So that is 1 divided by 20 you will get. But a delta L value not alone delta L. Delta L is multiplied with 10 power minus 4 they mention in the question. So here you have to take instead of delta L, so you need to multiply with 10 to the power of minus 4. This everything is the value of delta L by W. I will substitute that value here. So y equals to 1 divided by 10 power minus 6 into delta L by W means 10 to the power of minus 4 divided by 20. We can write 20 in the numerator. Okay. Now multiply. So y equals to 20 into 10 to the power of 10. Everything it becomes. So y equals to 2 into 10 to the power of 11. So this should be the answer for the given question. So 2 into 10 power 11, that is option is A correct for this. Okay. Next question is, this is 2013 advanced. Just look at the question once, pause the video and try by yourself. After that, you see the solution if you want. One end of a horizontal thick copper wire of length 2L and radius 2R is welded to an end of another horizontal thin copper wire of length L. The radius R when the arrangement is stretched by applying a forces at two ends. The ratio of the elongation in the thin wire to that of the thick wire is. Ratio of elongations they are asking, that thin wire to that of the thick wire. So first write the given data. This is the third question. So given data is not data, directly we will write that two wires we will take here. So let us take a wire of area of cross section. Circular wire we want a shape, not the divot. Let us take this wire. One is a thick wire and its area of cross section we can relate with the radius, but here radius is given as 2R and its length is given. What is the length of the first wire given? That is 2L. And there is a second wire. There is another wire also given and its length is less, smaller length wire, second one is. So from here to here its length given as L and a radius mentioned as R. Now here after this what they have done, now this arrangement they applied a force on this arrangement. Okay. So here a force F is acting towards right side and F is acting towards right side EF. Sir, how can you say that a force is set? There are two pipes or two wires arranged. We are only applying the force. Both the ends we are stretching. Okay, matlab we are applying same force you can consider. So force we are applying. Due to this force what happens? Both are elastic materials. So obviously some elongation comes. Elongation in the first wire and elongation in the second wire. We need to find out the ratios of elongations. Let us take this. I will take as elongation in the thick wire. So first of all, elongation delta L in the thick wire. So elongation formula is what? We know that y equals to FL divided by AL. So if I write the formula, y equals to FL divided by A into delta L, we will write. Elongation means delta L. So how to arrange this delta L? So that is FL divided by AY. Just to substitute that value here. FL divided by AY. So that is thickness, change in elongation of thick wire equals to how much is the force applying here? F. What is the length of the thick wire given? 2L. So F into 2L divided by area value. Here radius is given, so area of a circular cross section you can find out here. Sir, cylinder, na, it is a cylindrical area we have to take. Nah, we should not take cylindrical area, because where we are applying the force, we are applying force on this circular area of cross section. Here you may get this doubt, right? Because it is a cylindrical wire, so that area of cylinder we have to take 2 pi r into L we need to take. We should not take cylinder area, because where we are applying the force, we are applying the force at the edge of the given materials, and whatever the force I'm applying, that force is basically acting on the cross sectional area of the cylinder. So we have to take circular cross section, that is pi into r square. So area is pi constant. What is the radius of the first wire? 2r. So r square, that means 4r square we need to write. Young's modulus is y only. Let us take this is equation number 1. We got change in length or elongation of the thick wire. Similarly, apply the same formula for the thin wire. So that is delta L for thin wire. If you apply delta L for the thin wire, so formula will not be changed. Force is F. What is the length of the wire? Length of the wire is L divided by pi into what is the radius of the wire here? Second wire radius given in the question itself is r. So that this is pi r square into Young's modulus is y. So this is equation number. Now in the question what they're asking, just say this. The ratio of the elongation in the thin wire to that of the thick wire. Very carefully we have to analyze. Thin wire to that of thick wire, not thick wire to thin wire. That means divide equation 2 and equation 1. So divide equation 2 divided by 1. Because thin wire to that of thick wire they are asking. So which implies delta L for thin divided by delta L of thick wire equals to, thin wire means FL divided by pi r square into y whole divided by delta L. So reciprocal it becomes, so that directly you can write this as 4 pi r square into y whole divided by 2 into f into L. Whatever the terms gets cancelled, I can cancel here. Pi r square y cancel. FL gets cancelled. 2 one time, 2 times. So answer should be 2 for this question. So answer is 2. That is option C here. Next question is, this is 2015 advance. Very interesting question, but students get a lot of confusion in this. Basically, stress strain graph is a standard graph. Whatever the questions you see, most of the question, 90% of the question we can see that they will give strain along the x-axis. See, this is the graph it seems to be. We have to take a graph like this basically. In the class also we have discussed this model. But there I too have taken like this. Strain we have taken along x-axis. Stress we have taken along y-axis. And everything we have analyzed. So how to identify, what is the rule for this? It is based on Hooke's law only. And if any material is given, let us take for certain limit, every elastic material stress is directly proportional to strain. But this is not for infinite stress. There is a certain limit. Every material has a certain limit to hold Hooke's law. So if x-axis strain is taken, y-axis stress is taken, and here angle is theta. From this we can write, if slope increases, theta value increases. Of course, theta is more means slope is more. If theta is more means tan theta value is more. Tan theta value more means nothing but Young's modulus is more for this given graph. If x-axis, I repeat again, because this is the most important point. Along the x-axis, strain we have taken. Along the y-axis, stress we have taken. And here, due to the stress, strain is also increasing. And here there is a certain limit. Hooke's law holds only for certain limit only. Okay? Now, if slope is increasing, that means tan theta value is increasing. If tan theta increases, Young's modulus also increases. Young's modulus increasing means we can say that the given material is more elastic in nature. More elastic in nature. This is the basic graph, and whatever the required fundamentals are there, I have given here. Now you see this graph. Whatever the graph they have given, just observe. In this graph they mentioned stress is taken along x-axis. You need to focus what physical quantities they have given. Along x-axis what they have given, along y-axis what they have given. Here along x-axis stress is given, along y-axis strain is given. Whatever we have discussed is reverse. Strain we have taken x-axis, stress we have taken y-axis. Now analyze carefully. I will erase this everything. Okay, it is there in your notes. You can go through also. Just for a quick recap I have given. Else we keep aside a small. Aside I kept this one. Now we'll focus on this given graph only. What are the given options? Just to see the options also, we'll analyze one by one. P has more tensile strength than Q, they mentioned, first point. Then P is more ductile than Q, they mentioned. P is more brittle than Q. The Young's modulus of P is more than that of Q. If theta is more, then Young's modulus is also more, right? This is valid when x-axis is strain, y-axis is stress. But in this given graph, stress is x-axis, strain is y-axis. The graph which has more angle, that has less Young's modulus. But in option D they said that the Young's modulus of P is more than Q, they mentioned. No, this is wrong because the graph is ulta. I repeat, if theta is more, y is more is valid for this graph. Stress along y-axis, strain along x-axis. But a given graph is strain along y-axis, stress along x-axis. If theta is more in this case, that means Young's modulus is less. Here, ulta. So option D is wrong. Next, option C and option B we will verify. It is easy things. P is more ductile than Q. P is more brittle than Q. Ductile means nothing but material becomes very very thin and elongating nature also increases. If you see the given graph here, in this given graph, if you apply stress, which graph is expanding more? P is expanding more and more compared to Q. So definitely P is a more ductile nature than Q. So P is ductile than Q. Option B is right. Option C is wrong. Okay. Next option A will verify. P has more tensile strength than Q. So how to verify P has a more tensile strength or a less tensile strength? So for that we'll take the formula of stress equals to Young's modulus into strain, we can write, right? So here strain of P is more, strain for P dominates, so that's why obviously option A is also wrong. P has more tensile strength, yes. Why? Because the strain is more, stress is more, that means strain is also more. Stress is directly proportional to strain, we know. Stress is proportional to strain. Yes, strain is increasing rapidly for material P. If strain is increasing, we can say that stress is also increasing. So option A is also correct. Next one. Again, you try this question. Okay. So just to try this question also. A block of weight 100 Newton is suspended by copper and steel wires of same cross-sectional area 0.5 centimeter square and length length m and 1 meter. What is this? Area of cross section is 0.5 centimeter square and the length maybe 1 meter respectively. The other ends are fixed on a ceiling as shown in the figure. Okay. The angles subtended by the copper and the steel with the ceiling are 30 degrees and 60 degrees. Here let me zoom the diagram. You can see this clearly. Here length, here question some mistake is there, only m is given. Let's see the diagram so that we'll understand the question clearly, even more clearly we'll understand. Right, I just read the question once again. A block of weight 100 Newton means the force given directly. How much is the force given? 100 Newtons. Okay. Suspended by copper and steel wires of same cross-sectional area. There are two wires, both are having same cross-sectional area, that is 0.5 square centimeters. We can convert this into meter square. Of course, we have to convert. And their lengths also given. The other ends are fixed on a ceiling as shown in the figure. Means here the ends are connected to the ceilings and other ends are connected to the block having weight 100 newtons as per the question. Okay. Next. If the elongation in the copper wire and elongation in the steel wire, then the ratio of delta L by delta L. Okay, they're asking what is the ratio of elongations of the copper wire to the top of the steel wire. I think in this question some small mistakes they mentioned. Okay, so Young's modulus is also given. In this diagram, what we need to do, first of all, we need to resolve into components also. We need to find each and everything. How much is the tension force is acting. So all those we need to find out. Okay, sir. So for finding all those, let me draw the diagram for this. So this is the rigid support. Okay, a rigid support is given. Now here this is the wire having certain length. A block is connected here. This is another part. Different materials both are right. One is a steel material, one is copper material. And here a block is connected like this. Check it. Its weight also already given already. So this is block. Weight given as 100 newtons. Okay. And how much is the angle made by this string with the horizontal? 60 degrees. And here it makes 30 degrees. Okay. Now this is wire 1 which has a length 1 meter and this is wire 2. This is root 3 meters. And what type of wire it is? It is a steel wire. And this is a copper wire. Cu sometime right. Young's modulus of both they have given already. Now here what happens, what we can write, let us take tension acting in this wire is T1 I am taking and tension acting in this wire is T2 we can write here. Now total weight acts downward direction is how much? 100 newtons. Total weight acts is 100. Now resolve this into components. Let us take, there is a dotted line I have taken. This angle is 60, this angle is 90. So that what should be this angle we can take here? This angle value should be 30 degrees. Okay. Now this is 30 degree and this is again 90. So that this angle should be 60 degree. Okay. Now total upward force is balanced by total downward force. So resolve this into components. I draw the free body diagram here. This is the free body diagram. Draw. Downward direction on the block. How much is the weight acting? 100 newtons. Fine. Next, if you resolve this into components, what is the vertical component? T1 cos 30 will come vertical direction. This T1 cos 30. And what is the other force acts vertically upward direction? This is T1. As T1 cos 30 is over, and from the other way T2 cos 60. Okay, T2 cos 60. And along horizontal direction, what are the forces acts? This is T2 sine 60, and here left side again T1 sine 30. Now here the block is at rest. Block is not moving. Block is at rest means total horizontal forces are same, total vertical forces are same. So equate horizontal forces, that is T1 sine 30 should be equals to T2 sine 60. So T1 into sine 30 means 1 by 2, which equals to T2 sine 60 root 3 by 2. So here 2 and 2 gets cancelled. So T1 equals to root 3 times of T2. So we got here T1, T2 relation we got. Similarly, we can equate vertical also. Horizontal forces are balanced here. Because block is at rest, we can equate them. And vertical forces also we can equate. Because block is at rest, it is not moving. So we can write T1 cos 30, this everything is along x direction. Now this everything along y direction, vertical. So T1 cos 30 plus T2 cos 60 equals to 100, right? T1 into cos 30 means root 3 by 2, root 3 by 2 plus T2 cos 60 1 by 2, which equals to 100, correct? Next, to simplify this, whatever the information we have, we can substitute. T1 means how much? Root 3 T2. So T1 value is root 3 times of T2 into root 3 by 2 plus T2 divided by 2, which equals to 100. Clear? Simplify this everything, you will get T2 value. Root 3 into root 3 we can write as 3 T2 by 2 plus T2 by 2 equals to 100. So this is 4 T2 equals to 200. So T2 equals to 8 newtons. Right? T2 value we can. Sorry. So T2 equals to 200 divided by 4. So find out a T2 value. Now here we have just taken LCM as a 2. So 2 I multiply right side, it became 202. So 3T2 plus T2, 4T2 we have written. So that T2 equals to 100 upon 2, which can be written as simply 50 newtons. Right? 50 newtons we have written. T2 value we got means T1 also we can find out, because T1 T2 relation we know. Since T1 equals to root 3 times of T2, so therefore T1 equals to root 3 into 50. Root 3 into 50 newtons. So T1 value we got, T2 value we got. But in the question they are not asking T1, T2 value. What they are asking here, ratio of elongations of the wire. How much the wire can be elongated here. So that elongation we need to calculate. So for that elongations, what we need, I just give the equations, you simplify. I hope you can do this. Elongation means nothing but delta L equals to F into L divided by A into Y. Ratios they are asking. They have given force value. How much is the T1 value? How much is the T2 value? We know. What is the length of the wire? Length of the wire is also given. Area of cross section is given already. And Young's modulus of both the wires given in the question itself. So that you just substitute in this formula for both the wires and divide, you will get the final answer. Okay, this is the entire process you need to do for solving this question. Okay. Next question. I think this is the last question. After 2020, they may not ask any advanced question from this chapter. That's why I told it is a very small chapter, and they ask very limited questions in advance. But gravitation I will start tomorrow. That has very good weightage. Now let us see this question. A cubical solid aluminium, so bulk modulus is given this much. The block has an edge length of 1 meter on the surface of the earth. It is kept on the floor of a 5 kilometer deep ocean. Okay. Taking the average density of water and acceleration due to gravity to be 10 cube kg per cubic meter and 10 meter per second square respectively. The change in the edge of the block in millimeter is how much is the change they're asking. Okay. So just after seeing this question, I think you also got the idea how to analyze the question. Here they mention that bulk modulus. Bulk modulus is denoted by B. So B can be written as B equals to delta P divided by delta V by V. But here negative comes. Why negative comes? Because I already explained volume decreases inside the fluid due to additional pressure applied by the fluid. Okay. So how much is the value of B given? B value given as 70 gigapascals. Giga means nothing but 10 to the power of 9. So 70 into 10 to the power of 9 pascals. B value given. Next, an edge has a length. Length of the edge is how much for the given cube? So that is 1 meter they have given. And it's kept on the floor of a 5 kilometers deep ocean. 5 kilometers deep ocean they kept. So that means H value given. H value is 5 kilometers, which can be written as 5 into 10 cube meters. Okay. And acceleration due to gravity G equals to 10 meter per second square only. And then density given. Density equals to 10 cube kg per meter cube. If you observe this entire question, 5 kilometers depth. 5 kilometers depth means nothing but basically G value not actually constant, right? Because we know if you go depth, so as you are going depth, G value little bit variation is there, but as per the question they said that G value is a constant, so that we no need to change anything. Directly you can take G value as 10. Okay. Now, if I draw the diagram for this, for a better understanding, I just draw the diagram also here. Let us take the container type they have given. Okay. This end is not closed. Don't think that this end is closed here. It's not closed end. Okay, this is open everything because it's a sea. I have taken a tank just for understanding purpose. Completely filled with water. Why it has completely filled with liquid? Basically it is water. That's why water density they have given. Now here what happened? A block kept. At what depth the cubical block they kept here? Let us take this is the cubical block which kept at certain depth. The depth value also mentioned in the question itself. From the surface it kept at a depth of 5 kilometers. Okay. Right, 5 kilometer depth they kept. Now bulk modulus and pressure and volume, all these terms we need to relate. So equation we know. So equation for this is B equals to delta P divided by delta V by V. That V I will write here. Already I have written this equation in the above. B value given. So 70 into 10 power 9 pascals, right? B value given that 70 into 10 to the power of 9 pascals, which equals to delta P value. How much is the pressure? This is very important, delta P. Now let us see this question completely. See, when you are taking this cube, whatever the cube they have taken, and if you just keep inside, right, if you keep inside, excess pressure produced, delta P stands for change in pressure or excess pressure. Excess pressure is because of what? Excess pressure because of nothing but the fluid. So delta P value, how much we can write? Delta P value we can write directly rho into G into H. You understand why I have written delta P value rho GH? Because if the object is outside, let us take, if the object is outside, who will apply pressure? Atmospheric pressure P naught. Object kept certain depth. So how much is the pressure acting inside? That is a P naught plus rho into G into H. Let us assume this is the initial pressure. Initial pressure is P naught. What is the final pressure? Final pressure is P naught plus rho GH. Okay. Now what is the change in pressure? Change in pressure is nothing but final pressure minus initial pressure. So final pressure is how much here? P naught plus rho GH. And initial pressure minus of initial pressure is P naught. So minus P naught plus P naught gets cancelled. So excess pressure, whatever the excess pressure is there, its value is rho into G into H. So that's why delta P you can write directly. If you want a deep analysis, that is why I'm telling. Just learning the formula is different. Learn the formula in a detailed way. Okay? So loopholes you need to identify. And then you can solve the questions and easily. So rho GH is the excess pressure due to fluid pressure only. And here volume. Volume value not given, but for a cube length given as 1 meter. So that volume becomes 1 cube, which is nothing but 1 only. All divided by delta V. Right. Now whatever the values given, substitute here. 70 into 10 to the power of 9 equals to rho value given 10 cube. G value given 10 in the question. Depth is nothing but 5 kilometers. That can be written as 5 into 10 cube. All divided by delta V. Okay. Or else if you want to keep instead of 1, better you write V only. I will tell why we need to keep V. Delta V by V only I will write. Because if you see this question, what they're asking, change. This word important, change in the edge length of the cube. Change in edge length of the block, how much? So if you see volume of the cube is L cube, we can write, right? And change in volume, delta V can be written as units and measurements, error methods you all learned, similar to that. Delta V equals to 3 into delta A. This is not differentiation. Differentiation is different. If you apply differentiation here, L cube differentiation, basically you will write 3 L square dl, you have to write partial differentiation. That is not the matter here. Errors models you all learned in units and measurements, that we need to apply. So V equals to L cube. So delta V equals to 3 times of delta E. So from this delta V by V, how to write delta V by V? Just divide these two. 3 times of delta L divided by L. Okay. Now, instead of this everything, I'll write 70 into 10 to the power of 9 equals to 5 into 10 to the power of this 3, 3, 6 and 7 divided by. So I replace, since I will substitute here delta V by V, I will write like 3 delta L divided by L. So L value given 1 already. So entire equation we need to, delta L we need to calculate here. So delta L equals to 5 into 10 to the power of 7 divided by 3 into 70 into 10 power 9. Sir, L value 1 they have given already. So L value 1 no need to consider. If you simplify this, you will get the final answer for this change in depth. Here, I think this is the last question, right? These are the questions they have given till now in mechanical properties of solids. So in tomorrow's class, I will explain gravitation. After that, I will post either thermal properties or fluid mechanics. Whenever I am getting time, so I will record the advanced questions and I will post in the group. What you have to do before watching this, 2 things you have to do. Quickly revise your class notes, at least 15 minutes, all the concepts. And then don't watch the video directly. What are the solutions? First pause the video, you just to try yourself, after that see the solution. Even after listening this class, you may have 1 or 2 questions or cross-checking questions of the concepts. you can talk to me and you can discuss with me in the college. Okay, so take care, bye.